So hello everyone, a very warm welcome, a virtual welcome to you all from the sunny southeast. So I hope everyone is keeping safe and well, and also a very warm welcome to our presenters today from the Three Counties Energy Agency. My name is Colm Callery, I'm Chair of the Southeast Region Committee. On behalf of the Southeast Region, I'm delighted to welcome you all today to today's webinar, which is part of the Sustainability Grand Tour. So it's designed for manufacture and assembly a digitised solution to low carbon modular homes. So the Sustainability Grand Tour is a collaboration of our sectors, including our West, Cork, Southeast, Great Britain, Northeast, the Northern Midland regional branches, and our Energy, Environment and Climate Action Division and Roads and Transportation Society. So this follows a request by the current President of Engineers Ireland, Maurice Buckley, last summer for sectoral projects in support of national recovery. So it's been an incredible success to date, and this is the 8th lecture in the series, which brings us about halfway through the series. So there's going to be lectures all the way up to the end of April, so plenty to look forward to. So back to today, the Three Counties Energy Agency is a non-profit, independent energy agency working primarily in Carlow, Kilkenny and Wexford. The agency has a voluntary board of directors drawn from the private, public and community sectors. So I'll now hand you over to John Carley, Chartered Engineer and Fellow of Engineers Ireland, and also a past chair of the Southeast Region Committee and current chair of the Three Counties Energy Agency, who will moderate today's lecture and introduce our speakers. So over to you, John. Thank you.
Thanks, Colm. I'd like to first thank yourself and Engineers Ireland, and I compliment the President on this initiative. I think it's a great idea, and I think it brings sustainability to the profession and to the wider public. I am Chair of the Energy Agency. I'll introduce the other speakers in a few moments. I'm a retired local government official. I graduated from Bolton Street and Trinity College way back in, for the want of a better word, old God's time in 1979. And I've worked in consultants, I've been a resident engineer, and I've been in local government since the early 80s. And I've worked in Offaly, Carlow, and Wexford, and back to Wexford again at the end of my career. I was responsible for management and delivery of various services and infrastructure across 3 counties. I'm a chartered engineer. I've served in 2 regions. I've been on the council and the executive of the institution, and I've also been on the accreditation board for some years now. And would recommend to any engineer that's in the profession to give back to the region and to other committees that are, because without those committees and without people giving volunteering, the profession wouldn't be able to do the work it does. We have 3 speakers today from the agency, and maybe we'll pass on to the next slide now, where I'll just explain we're a regional energy agency. We have an office down in Kilkenny. We were founded in 2002 by 2 local authorities, Carlow and Kilkenny, and by the local leader development partners. We're a not-for-profit social enterprise, and we produce independent advice, and we're in the space of being a trusted intermediary, particularly in the energy saving area, but also now we're moving more and more into climate change and emissions reduction in accordance with our climate responsibilities. Next slide. So far, we're playing a strategic role, and we're partner with our members and supporting all stakeholders in an energy transition journey. That's our mission. At the moment, you see a map there that shows 3 counties, and we're now in a position to tell you that we're in I want to add a blue coloured jersey to it from Waterford, in that Waterford have become part of the company. To date, in terms of 2013 to 2018, we've delivered approximately 34 million in capital expenditure with our partners. We've had 12 million euro of an avoided spend, and we've had 54,500 tons of a cumulative CO2 reduction. Next slide, please. Last year, we launched our transition strategy for the Three Counties Energy Agency. This is working with various partners, various stakeholders, and raising awareness, providing support, and delivering the low carbon journey. We're aiming to work with all of the partners in the region, both regionally, countywide, locally, and nationally. And we do a lot of work nationally with a lot of partners. With that, I'll introduce you to our next three speakers, which will be Ralph Camp. He's one of our EU project officers, and he's an architect by profession. Alex Hamilton, who's a senior engineer in the Energy Agency and is a civil engineer by profession. And Sean Savage, who works with one of our partners. He's an architectural technologist in the Housing Capital Programme in Wexford County Council. We have 4 or 5 projects that we're working on with the EU. We seek funds from the EU and we find partners, both in the EU, outside the EU, and in Ireland. And we work with them. We've a data for action, Streetlight EPC, Reg Energy, Energy Watch, Steps, and the one we're talking about today is Housing for Energy, digitisation of and modular low build and low carbon homes in a modular form. With that, I'd like to thank everybody for coming today, and I'll hand over to Alex.
Thanks very much, John. Can everybody hear me okay? Could everybody see my screen?
Yep.
That's great, thanks very much. So thanks again. A number of innovative projects at the moment. And this particular project that we're talking about today is Housing 4.0 Energy. So Housing 4.0, it's an Interreg Northwest Europe funded project, and there's 7 partners across the Northwest Europe there. You can see on the map. Netherlands, Belgium, Germany, the UK, and ourselves in Ireland. The project is the aim of the project is to facilitate the uptake of low carbon technologies, products, and processes to reduce greenhouse gases. So that's the overall aim of, or the goal of the call for the project. And this particular project, Housing 4.0 Energy, the aim is to reduce production costs of new build housing units by 25%, and at the same time to reduce the CO2 emissions by 60%. Now that's CO2 emissions of the embodied materials and the operational use of the house. How are we going to achieve this? Low carbon design is obviously critical, and my colleague Ralph is going to talk a little bit more about that after me in a few minutes. So particularly looking at the low embodied carbon materials, in terms of the NZEB and the new Part L technical building regulations, you know, our energy ratings and our energy building of homes and buildings now is already quite low. So what are the other options of reducing the carbon emissions? So looking at better or lower embodied carbon materials. Also looking at the logistics and the procurement, looking at local contractors, local supply, the less transportation that we have to site of materials and of M&E systems, etc. Obviously, the less transportation, the less carbon emissions that are relating to that build. And finally, and again, what I'm going to go into a bit more detail about now is the digital platform. So how do we replicate the designs of these homes to make it more replicable? And therefore, if it's more replicable and easy to use by clients, by designers, by homeowners, by housing associations, etc., then will that reduce the cost? So Housing 4.0, based on, or the original idea, again, when this project conception started back in 2015, 2016, we were looking at the Industry 4.0. So the trend of automation and data exchange in manufacturing. So digitalization, using smart technologies, using data exchange. So how can we bring all of that together in terms of housing? So design for manufacture. I'm going to not talk too much about this because I'm sure that you're all well aware at this stage. Design for manufacture, design for local manufacture, which again looks at the reduction in the need for transportation, and again the reduction in CO2 due to transportation, so keeping everything local. And then again, design for assembly. So our design for manufacture and assembly. So that's the model that this project is based on. So what can we do here in Ireland? We're working with a number of partners across the EU who are, again, some of which are in much more advanced stage. And the idea behind the Interreg funded projects is that we learn from our European partners. We're not trying to reinvent the wheel here. There are plenty of people and plenty of countries doing this already. And how can we learn from them, and how can we increase the uptake of such design for manufacture and assembly here in Ireland? Very simple couple of examples, just to give you an example of what we mean by design for manufacture and assembly. Here's a car, the end product is the car, and we look from this very start, what materials are we using, each of the different parts that come from the different various suppliers along the supply chain, assembly in the factory, and then the end product is the car. So that's a very simple one. At the same time, another very simple one, and I'm pretty sure I would be very, very surprised if there's anybody on this webinar today who has not put together some kind of IKEA or other piece of furniture. So it's exactly the same idea here. So we start with our material. Each of the parts are made individually, and then you purchase the product and assemble it yourself at home and end up with the end product. And if you have a screw left over at the end, you know you've done something wrong. That's if it's IKEA anyway, it's all very exact. And in exactly the same way, we're trying to bring that idea to a larger scale in terms of our end product being a housing unit in this particular case, in this project, Housing 4.0. So modular build of homes, easy design, low carbon materials, supply off-site, assemble on-site. And again, how we're looking to do this within this project is by creating and developing a digital platform. So we're working with our 3 partners here in Ireland, and again, there's 4 or 5 other partners across Europe doing similar. So the pilot sub-partners in Ireland, Carlow, Kilkenny and Wexford local authorities, are all designing and building their homes. And we are taking that information from the homes that they are, the units that they are designing and building, and creating a digital platform. So all of that information will be open source, and all of that information will be available to use by the local authorities, again themselves, by other local authorities, by other housing associations, or indeed by individual private homeowners who want to build a modular low build home. So the idea of the platform is that we get all of the individual components, the 3D components, and all of the rules of the data, and it's put onto the platform. The client or the customer comes along, designs their house, and the platform will send out or create the bill of quantities, basically the bill of materials, send it off to our local manufacturers and installers, and the unit can then be manufactured and then built on site. The digital platform, the back end view. So again, the top is what our end user should see, and I have another picture at the end. Again, it's in development, so this isn't the final version, but this is just to give you an idea of what we're developing. So the user interface at the top. So that's what the user sees. I want to build a house. This is the type of units I use, and the back end is all of these, what we call the hanger configuration. So the different envelope types, and then how it's all pulled together. From a user point of view, though, then what that does is it allows the end user, the private homeowner or the housing association, whoever it is that's using the platform to design their home or their houses, to come up with a detailed bill of quantities, which will give a detailed cost. And also, again, very important to this project, an energy consumption, an energy usage performance of the building, based on all of the details of the different material types, of the building envelope, of the mechanical M&E systems, etc., that the user has chosen. I've mentioned already our sub-partners, Wexford County Council, Carlow County Council and Kilkenny County Council. So we have Sean from Wexford County Council, and again, he's going to go into a little bit more detail about their specific pilot, which is a block of apartments, 4 units, 4-unit block of apartments. In terms of innovation and replication, the digital platform, it's essential that we get as much information on the platform to make it usable, but also that will help with the scale and ease of using the platform, and will lead to the cost reduction. So again, one of the aims of this project was a decrease in construction cost of units by 25%. And we've looked at doing that by, again, providing these pilots. And again, there will be other design and other building systems that are being used by the other partners across Europe. They will all be available on the platform for everybody to use. Necessity for using the non-fossil products. So the low carbon element of this project is absolutely critical. Again, I mentioned before the new building regs, part L. We're already building much more energy efficient homes than we used to, but what are the other ways? And looking at different materials is absolutely critical, and different piloting some new technologies. Again, Ralph's going to go into that in a bit more detail in a minute. Again, giving confidence to the users of the platform is absolutely critical to making sure that we're getting certified products. So every product and every building system that is on the platform that we're piloting through the pilots, and others that we're not using through the pilots, but there are others that have come to us with their information that want to be on the platform. So making sure that it's all certified, it's all meeting building regs, it's all meeting, it's all NSA certified or equivalent, etc., is absolutely critical to the project in terms of giving the end users the confidence that the home that they will get in the end is up to standard. And obviously working across the supply chain is absolutely critical. So again, just for anybody out there, this is a quick introduction to the project in 10 minutes. But if there's anybody wanting more information, wanting to get involved, wanting to have their products on the platform, etc., then please make sure to contact myself or Ralph after today, anytime we're available. So that's all from me. A quick, very quick whistle-stop tour of Housing H4O, introduction to it and what we're aiming and trying to achieve. And I'm going to pass you on now to my colleague Ralph, who will go into a bit more detail about the low carbon side of things.
Can everybody see my screen and
Yep.
hear me?
Yep.
Good. Okay. Yeah. Hello, everyone. My name is Ralph Kampen. I'm a member of the 3CEA technical team, originally an architect. And I want to talk about savings of embodied CO2 emission in the H4O pilots. H4O and Ireland are social housing projects in Wexford, Carlow, and Kilkenny. And we at 3CEA are working with the county council to achieve the H4O targets, which are 60% CO2 emission savings and 20% costs. My focus today is on the savings of carbon emission, how we aim to achieve that. Most people are only looking at the reduction of the operational energy used to run the building. Operational CO2 emissions are important. However, upfront embodied carbon emission should be equally important. For example, this building, a building to the current standard has consumed 45% operational and 46% embodied energy after a lifespan of 50 years. If you look at the impact of the CO2 emission of that building within the next 20 years, we are at a level of 68 of the upfront embodied and 32 of the operational CO2 emission. That means that the major impact will be still the upfront embodied CO2 emission. And sorry. I'm stuck here. Yeah. So that means that the major impact will be still the upfront embodied CO2 emission, and that was used to build this house, and that is what we need to reduce as well. And also we should know that the weight of the upfront embodied CO2 emission will be even increased when we move from NCEP buildings towards zero energy buildings. Full life cycle assessments, cradle to grave, are very important contribution towards a sustainable future. However, it's crucial for climate change mitigation to reduce CO2 emissions now and within the next decades. We are planning to achieve our savings by substitutions, which are low embodied carbon building methods, low carbon and renewable building products, and recycle aggregates. The financial sector has as well a big influence and can support. Climate change is meanwhile accepted as a financial risk. Therefore, green investments will be preferred. And cheaper capital is also accessible. Regarding a new EU taxonomy, building developments are green investment if the benchmark is at least 20% lower than the minimum requirements. And we are sure that an upscaled H40E project via the platform will be a green investment. So our comparison scale, why we need this? We need to find out which substitution or combination will achieve how much savings we need to achieve. We develop a detailed program for a baseline construction type and for improved types. The detail development include an analysis of the U values, humidity, drying reserve, temperature, summer heat protection, and an LCA assessment based on EPD information from the used material. So the LCA will an A1 to A3 cradle to grade analysis. And the basis for these calculations are the quantitative surveys of the Irish pilot designs. In order to make the comparison, we used a calculator called Ubacus, and we designed the various details of the construction types with the aid of this tool. This tool calculates the LCA based on the construction details. We have 5 different construction types, and shown here are the wall build-ups. Baseline, the first one is a baseline. It's an Irish standard concrete brick, and the second is an ICF, an insulation concrete framework. The third is a standard Irish timber frame applying to IS 440. And the fourth one is Irish timber frame applying to IS 440 and so using low carbon and non-fossil based product as much as possible. And fifth, I called it an EU standard. It's actually so details used commonly in Germany. It's a timber frame with mostly renewable products, which stores more CO2 than emitted in A2-3, also in the source and production. As an example, I choose Carlow. It's a Carlow pilot, because it's the most developed pilot, and all pilots are varied in size, scope, and construction types. So, and with this sample, we show the Carlow project, and the CO2 saving method is ICF, and we're using GGBS as GGBS cement ratio and then RCA and recycled aggregate ratio. So this graph shows the Carlow pilot upfront embodied CO2 emission with GGBS substitute. The bar diagram showing the Carlow design and how it's performing with the different construction types. The orange line shows the CO2 savings compared to the baseline. The baseline is a standard NSAP building with a minimum required backstop values of TGD to 219, 2019, with a circa BER rate of A2. So, and has no low carbon substitute methods or material as the baseline. And here we see so which construction type also which can achieve CO2 savings. We see here that the ICF is lower than the timber frame, and that is related to the IS 440. That's a guideline for the timber frame here in Ireland, and it's more or less dictated using lots of fossil-based products. So we come down to a big saving with a low carbon timber frame. Okay, and yeah, this is the result of this tool, and that's actually a start for the project. Also from here we can start to develop that. The conclusion is we need to reduce CO2 emission now and within the next 20 years to mitigate climate change. A big impact will be upfront embodied CO2 emissions, and we need to identify the upfront embodied carbon emission of the construction type. Will be a first step into a sustainable design approach. And then combination of substitutes can help to achieve this. Identifying the upfront embodied carbon will be part of the H40 platform. So there will be as well a carbon calculator, and that will be an add to the upscaling process. So that's all what I want to say today, and say thank you and hand over to Sean.
Thanks, Ralph. That was a very good summary of the project and the aims and achievements by Ralph and Alexandra there. I suppose I'm just going to talk today about our specific project in Wexford. It's a 4-unit, 2-bed apartment block in Gorey, 2-story. It's a social housing development, and it's on a greenfield site on the edge of town, just connecting into the infrastructure of an existing surrounding estates in the area. As was set out there, the challenge is to look at reducing both the embodied and operational energy by 60% compared to our standard build. Now, our standard build for a development of this would have been cavity block construction to NZ standard. So there is a good bit of scope for the embodied energy. The operational energy is a bit more of a challenge, but the combined of both reductions in embodied and operational, we hope will be in the order of 60%. But as this is a pilot scheme, it's an area of exploration. We're going to see how far we can get it and see if it is achievable within the constraints of the budgets and for the project. So we need to consider essentially design and also procurement for the building. The design, we're using a timber frame structure, open panel. In terms of focusing on what we will eventually build, we're very cognizant of the fact that it can't be a completely bespoke build. This needs to be available to be constructed by multiple timber frame companies out there and in compliance with all the relevant building regulations and other regulations that apply to building, particularly fire and all the rest. So we can't just go off and design and invent a new system that isn't practical and deliverable. So we focused in on 3 areas to try and reduce the carbon, the embodied energy in particular. Going with timber frame, some initial modeling done by Ralph. We focused in on if we could eliminate PIR insulation, that would really drive down the embodied energy of the timber frame kit systems. So we're looking at alternative insulation such as wood fiber, mineral wool, and seeing what's available, what's practical, and what we can get delivered in the timescales. The second area that we're going to focus in on is the use of GGBS cement in the floor slabs. It's an easy gain as such in terms of embodied energy. It leads to a good system is readily be available. And then the third item that we're looking at is the heating and ventilation and possibly the use of additional PV panels, which would drive down the operational side of things. But coming from an NZEB base, we'll have to see how far we can push that. So as I was saying there, we can't just go off and do a bespoke system. We need to design and spec something that a builder can go off and price and deliver to site, and within the budget of the project. We looked at some procurement routes, possibly going out for a specific tender just for the timber frame package to see how far timber frame companies could push this, maybe waste the embodied energy in against the costings, and seeing where that goes to do a nominated subcontractor role. But with the design input of the of the energy agency, we feel we can do a lot of that assessment beforehand and see what kind of systems that are available on the line will drive down the CO2 the most, the embodied CO2 the most. So we're just going to go with a straightforward tender for the project. So it's the involvement in the pilot scheme. It's a little bit more paperwork, it's a little bit more design work for ourselves, but I think it's well worth taking a step back every now and again and reassessing what we do, especially faced with the challenges of climate change. And if we can look at how we can produce lower CO2 in buildings within our constraints and budgets, I think that's a very worthwhile thing that Wexford County Council can be doing. The platform that Alex mentioned there looks like it's going to be a very useful design tool in the future, particularly at the early stages of a project, and when CO2 emissions are factored in more to future projects. So essentially what we're trying to develop there is a design tool that will give you embodied energy calculations for a building for a specific site, which is very interesting for the future. So that's what we're trying to do in Wexford County Council, and I'll hand you back to John there for questions.